Hey, okay, so I managed to tweak the ShiftBrite code from Ashley Hughes. I'll just show you. So I combined the ShiftBrite code from the Ashley Hughes library with some old Arduino code that I had for running servos off of a couple of like analog potentiometers. And so I have a lot of legacy comments in here. But if you look at it, here's the old code that was just basically cycling through the different colors. And what I'm doing is I declared some variables up here that are reading the voltage on analog pin 0 and 1. And since I don't have another 10K potentiometer, I'm just using, the 2 to run 3 colors. So what I did was we have value 1, analog pin 1, volume 1, and then I map the value to 0 and 1023, and then you have the option of additionally mapping the value from 0 to whatever. So this tells you what the value is on the analog pin, and this tells you what value you're shuttling out to the digital pin, so you're reading it. So you can actually do a neat little conversion there. So let's say from 0 to 1023, those are the amount of steps I have on my potentiometer, but then I can go like 0 to 100 to calculate percentages, let's say, if I wanted to do math that way. But right now it's 1023 because, as luck would have it, that's the maximum step value for the ShiftBrite code, so it matches perfectly. So I have value 1 and value 2, and then I pass it all to send color to SB ShiftBrite SB. So value 1, value 2, value 1. So if I had 3 potentiometers, I would have value 1, value 2, value 3, and that would be able to control my RGB values. So right now it's controlling the RGB, but value 1 is controlling the red and the blue together, so I always end up with this weird magenta color. And then the delay is 15 milliseconds. So that's pretty cool. So right now I have it running. I ported that Arduino sketch over to the board. I'm just running like a nice little proto shield here. I got my potentiometers. This is pot 2, pot 1, or pot 1, pot 0. So 1, 2, 0, 1, whatever. And there's my ShiftBrite. So when I shift my color values, I can actually turn it all the way off, turn it on. That's a nice green color. I can, here, let me turn it down so it doesn't look white, it looks green. Can you actually pick that up as green? Maybe. Anyway, so yeah, so I can do green, and then I can do red and blue together, and of course that makes this really neat kind of magenta, or, well, according to this thing, there we go. Nice magenta color. Here, let me turn off the lights and see if I can get a better color value here. Oh, oh no. Yeah, maybe. If I don't look at it directly. There we go. So where am I? There we go. So I can turn that down. There, nice and purple. And then I can turn up the green. Turn up the green. Oh, it's so very green. Huh? Isn't that cool? It's very green in here. And now I'm going to make it white in here. Nice kind of white light there. Isn't that groovy? So that is how you control ShiftBrites with an analog input. Conceivably, instead of using potentiometers, I could just use button clicks, and then instead of listening for a value between 1 and 1023, I could just listen for a value between 0 and 1 and have that set a little toggle in the Arduino code that would change this ShiftBrite to a preset value. So if I wanted to shift between red, green, blue, or any color of the rainbow, I can just put in my preset mixes and then attach it to whichever analog button gets pressed. Now, the cool thing about ShiftBrite, the shift idea, is if you look at it, here, let me just turn this off. If you look at the ShiftBrite, right here, you'll notice that it's got two sets of header pins. One set is for signal in, and one set is for signal out. So you can actually sort of, here, let me get another one here. You can daisy chain them together, and it's actually got a little microprocessor in the bottom that sets up timing values and stuff. So I can send commands to this one, and then this one's waiting, and then when this one gets new commands, it dumps its memory into this one, and then this one starts running this one's old commands. So if this one's red, and then I shift it to green, then this one turns red. And then if I shift this one to blue, then this one shifts to green. You know, and you can actually do that all the way down the line. So you can have like hundreds of these put together, and you end up with this really cool kind of spectrum pattern. You can also have it so that it, instead of sending color data, it sends timing values. So you can have it so when one shifts, they all shift the same color, or when one shifts, they all shift, you know, sort of, you know, down the line, like, you know, with a delay of like half a second or whatever. So this one shifts red, and then this one shifts red, and then the next one shifts red, and it keeps going on. So doing that, you can actually make some really neat effects, like, you know, the Kit Car Knight Rider back and forth kind of Cylon light. You can do that really easily with these things just by setting a couple of really simple values and delays and clock timers. So I have to figure out how to do that in the code. And then I should be able to do some really neat sort of computery special effects with these things and the infinity mirror, which is going to look really neat. So I like this little prototype thing. It looks very cyberpunk. It's kind of cool. Yeah. Oh, if you want a close look at what I did, there. Freeze frame it. And then map the wires out. No. Okay, so we have, here's your power rail here. You have like 3 volts ground and then 5 volts. So I have everything hooked up to 5 volts. So a lot of these over here, like this little madness bit here, this is all just jumping from the 5 volts that are going into the ShiftBrite. I'm just taking 5 volts in ground and putting them over here. And then these two guys get mapped out to the analog pins, analog 0 and 1 over here. Okay. Yeah, you can't see it, but it's analog 0 and 1 right there. And this guy here, boop, 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 in the ShiftBrite code that Ashley Hughes has graciously supplied, she says by default it's just mapped to the digital pins 10, 11, 12, and 13. So, yeah, respectively, you know, it's, let's see if I remember what these are. You have data, latch, echo, and clock. Is it echo? I don't know. Just check out the ShiftBrite website for what these little things mean. Anyway, all the documentation is there. I'll leave the links to the resources that I had in the crotch bar, and maybe I'll upload the sketch, the Arduino sketch, when I'm finished of how to get this thing working with analog, because I haven't seen that too much. I haven't seen anyone use ShiftBrites and tweak them, like be able to control them with a remote control. I guess that's kind of specialized, but you know, it'd be kind of neat to actually have some dimmers to set the mood lighting for whatever you want. Yeah. Anyway, bye-bye.